Okay, take 3 I think on this video. Hopefully we'll get going with it. So we're going to do a video on analog to digital conversion. The basic premise of doing analog to digital conversion is nice and easy. There's 3 analog to digital converters. Most of the time we use ADC 0, which is connected to port A bit 0. And all we have to do is use the inbuilt subroutine, so call read ADC 0, and it will take the analog voltage that's present on that pin and convert it into a digital value. Okay, and that's nice and simple and nice and straightforward, but we just need to understand exactly a little bit more what's going on with that. So let's go into that. So 2 parameters we need to know to start with is the range, so what input values voltage can we have on our ADC input. So range on this one would be 5 volts, and the result that we're going to get out is going to be an 8-bit value. Okay, which means we can then work out what the resolution is. So we're going to have 5 volts over 255, which equals 19.6 millivolts, so we'll say approximately 20 millivolts. Resolution is sometimes known as step size. Okay, the reason why it's step size, so have an 8-bit value, all the zeros, then that could be anywhere, then the analog input value could be anywhere between 0 volts and approximately 20 millivolts. And then the next step from that is when we get a 1 out from conversion, and that could be anywhere from 20 millivolts up to 40 millivolts, etc., etc. And we keep going up, so that's why sometimes it's called step size. So how does that help us? So if we take an example, if we connect some sort of analog input to the ADC, so a light sensor, and we've configured our light sensor so that when it gets dark, the value that we get from our light sensor goes greater than 3 volts. Which means we can then work out, well, how many steps have we gone up? So if we take 3 volts, divide that by our resolution, 20 millivolts, tells us that we've gone up 150 steps. That's a decimal value. We can leave it as a decimal value, as you'll see in a minute. That'll come in handy. So that's what we expect. That's what we expect our conversion to be. Now we can understand what it is in binary, but we can we'll leave it in a decimal. So what we're going to do is we're going to write a little bit of code so that when it gets dark, when we get an output from our sensor of greater than 3 volts, 150, we turn on bit 0 on port B. Okay, if not, we'll keep going around until it is. Okay, so what we're going to do is so we're going to read our ADC, and that puts the value into B0, but we don't want the value in B0. I want the value in the working register, so therefore I've just done another move command to move it from B0 to the working register. Okay, and then the next thing I'm going to do is I'm going to use this subtract command that I've used before, and this is where the 150 comes in. So I'm going to take use the 150, and I'm going to take away from that what's in the working register. Why am I going to do that? Well, okay, so if the value is greater than 150, then what we'll do is effectively we'll be getting a negative value, but the bits will roll round, the same as when you add bits together. You can get what's called a carry. So when it rolls round, we get a negative, then we'll get there'll be a flag that's raised, it's a carry flag. So we can use that to indicate whether the value is greater than 150. Obviously, if the value in the working register is less than 150, then we won't get a carry. I hope that was okay. I thought it was better to talk about that than going into the realms of subtractions and 2's complements. Okay, so what we're going to do is we're going to do a bit check, and we're going to check the condition of the carry flag. So if the carry flag wasn't set, then it wouldn't skip this next line, so we can tell it to just go back and go to begin. But otherwise, then what we want to do is we want to set bit 0 on port B. And there we have it. There's our code to make a decision. There are a couple of other ways of doing it, but I think this is probably one of the better and more elegant ways of doing it. But as I said, there are a couple of ways that you can do, and you can read the ebook and a few other examples online.